Namaskar, my dear friends. So let us see linear regulator component selection process. So there are several kinds of linear regulators. We have SOT package, or we have DFN package, or you have WSN package, and with different like current parameters and all. So first of all, in this tutorial, what we'll see is we'll try to find out what are the different selection parameters and why do we need first linear regulators, that I'll tell you, like whether it is a microcontroller circuits or FPGA circuits or any other like analog circuits. So microcontrollers, FPGA or analog like parts of your schematic designs, everybody requires power supplies, and those power supplies can be given by either switching regulators or linear regulators, but linear regulators are preferred because of very low noise. Okay, so these are the reasons we use for linear regulators in different circuits. Now we'll say like talk about what are the different selections parameters. So first of all, you have to decide which manufacturers you want to like go ahead. Maybe some people are like interested into analog devices, or let me take you the companies. Some people are like interested into analog devices or Texas Instruments or Microchip or Renesas or Infineon. ST Microelectronics also have like broad range of linear regulators, but mostly I'll suggest you analog devices, which is like a combination of linear technology and Maxim integrated. So linear technology was one of the best company, and Maxim integrated for linear regulators or power management devices, and they have been acquired by analog devices. Okay, as well as Texas Instrument is one of the leading company for very wide range of linear regulators and that is also low cost. Okay, even Intel is producing linear regulators, but that is only for SOCs and FPGAs. Okay, good. So once you decide your manufacturers or something like that, even if you don't decide manufacturers, that doesn't matter. Based on the availability of suitable linear regulators, you can decide your manufacturers. Okay, and this is your manufacturers done. Coming to the description part, what are the parameters that you need, like whether it is a SOT package or whether it is 100 milliampere or 1 ampere or it is SMD or it is through hole. So all these things will come under your description parts, that will be like given one by one. What is the output type? Output type may be possible like it is a fixed regulator or it is adjustable regulator. So let's say you need 3.3 volt output. So you will be going ahead with fixed regulators, or you may need 3.1 volt sometimes or 3.7 volt sometimes. Okay. So that time you may go ahead with adjustable, but adjustable also can go 3.3 as well. But generally people do not like prefer to design the resistor, like voltage division resistor. This will be your V out, this will be your R1 R2, that will be going to your feedback of the regulators. Okay, so these resistors R1 and R2 people do not want to design on their own because they may have some tolerances which will differ and that will change the value of V output. Okay, so that's the reason people go ahead directly with fixed regulators that has better accuracy and tolerance. Now, how many number of regulators circuits that you will be needing in one regulator? Maybe it is one, or dual regulators are also coming, triple are coming, quad are coming, even 5 outputs are also there in the regulators these days. Okay, so generally people prefer one or two outputs. So I am going to take up one outputs right now. What is the V input range? So what is the minimum input range? Let's say you need 0.6 volt input, or let's say 20 volt input, or let's say 36 volt input. Maximum like up to it can go 36 volt or 40 volts input. Okay, so based on the things that you decide, V in range you can find out. But still I'll suggest you don't have to worry about defining each and every parameters while selecting the regulators. I'll tell you a method how you can make your job easier. Okay, while selecting the regulators. So hope you have a good idea. Now coming to the uh, parameters package. Okay, so this package parameters, What are the different packages that is available with linear regulators are like SOTs, WSON, X2SON, VSON, and even bigger package are like TO220, TO263, TO252, DD-Pack. Like these are bigger package, and these are bit like a smaller package. And this even DSBGA package, like this is ball grid array. They are basically used in variables and all, where a lot of time like space constraints is available there. Basically they are going ahead with DSBGA, and even LFCSP package are bit smaller. LFCSP package has good advantage is that it has a heat like a pad. So there is thermal pad that will be helping you to dissipate the heat at like greater level. So basically package is decided based on the heat dissipation capacity that you need in on your board. So let's talk widely about the package. So these are the packages that I showed you in the previous slides. These are SOT223 package. This has good amount of heat capability. This bigger package is there, like this head, that is going to help you to spread lot of heat, and it will save your device to get heated up to higher temperature. Okay. Even SOT package are more general. This is very general package. Okay. 3-pin package, or even like 5-pin package or 6-pin package. So this is very good, like input, output, and ground, as well as input, output, and some feedback resistors, and not connected pins that will be there. XON package is coming up these days because of like very small applications like wearables or smartwatches or something like that. VSON package are the same way, and WSON package, even BGA package I told you, for very small like portable devices. One very good advantage of the linear regulator of this SOT89 package is with the same like area almost, this has greater capability of heat dissipation. So this has very good thermal like power dissipation. If you need even like good handling capabilities, like you don't want to handle with uh, I mean SMD package and all, then you can go ahead with through hole package like PDIP package. Okay. The regulators are coming in SOIC and TSSOP packages also, HTSSOP package also, TSSOP and HTSSOP, SOIC, all those things. Even VSSOP package are also available. Now coming to the fact that very high current regulators, let's say 1 ampere, 2 ampere, 3 ampere, all those things. So for that, you definitely go ahead with like TO220 or TO252 package, and TO220, as I already told you, this is 3-pin package, this is 5-pin package or 7-pin package. This is TO263, that is DD-Pack package. So these big packages are basically like going to help you for your good thermal heat expansion. Okay. And thermal heat expansion I mean to tell you is let's say there is something called as like theta JC. Okay, that is thermal heat capability, which will be giving you our thermal heat resistance. Okay, so that is going to give you, let's say, 33 degrees centigrade per watt. It means suppose 1 watt of dissipation is there across the IC, it means your temperature will increase by 33 degrees centigrade. So you have to understand, let's say your ambient temperature is 25 degrees centigrade, and you are going to dissipate heat around 1 ampere, I mean around 1 watt across this, then the temperature will increase by 33 degrees centigrade. Okay, and how does it like calculates that, I'll tell you. uh, Let me take a separate sheet. Let's say this is your V input and this is your V output. Okay, and let's say this is your 12 volt, and you are going to take here 5 volt. So the difference between these two is actually 7 volt, right? So 7 volt is the voltage drop that will be there across the device. Okay, now suppose the current output that you are going to take is, let's say, 1 ampere. Okay, so if you're going to take 1 ampere, it means 1 ampere is flowing across this. Then what will happen? 7 volt into 1 ampere, that is 7 watt. Okay, so like that will be the like heat dissipation that will be there across this. And suppose your thermal resistance was 33 degree centigrade per watt, it means 30 multiplied by 7, let's say it is 30. So 30 multiplied by 7 is around 210 degree centigrade, it will increase. So this is not suitable at all for your design, right? So you have to look into your theta JC parameter. Okay, good. So coming to the fact of next parameters, as we have studied about the different packages that is available with the linear regulators. Now what are the more different parameters that we go ahead? So we definitely try to see what is my what is my voltage drop across the LDO. Let us say you have an LDO, this is your V input and this is your V output, and let's say you have 3.8 volt available and you need 3.3 volt. So what is the room that you are having? Just 3.8 to 3.3, that is 0.5 volt. So your the voltage drop must be less than 500 millivolt. Okay, so this is how the thing is. So generally all the LDOs which are available in the market, that are coming up with around let's say uh, 150 millivolt to around 600 millivolt drops. Okay, or 660 millivolt drop, not more than that. All the LDOs are coming less than 0.7 volt drop. Okay, so you can see what are the drops that is available, and if you want very less drop, then you can go ahead with high end regulators. What is the line regulation capabilities? Let's say it is like 2% or 1.5% or whatever it is. Load regulation, uh, is the same way, like let's say 0.5%. So lesser the better. Okay, if load regulation and line regulation both are small, or it can be given also in ampere by ampere rating. Okay, so if it is less, then it is good. Okay, now shutdown current, how much shutdown current it is going to take? Let's say the system is in a shutdown mode or switched off mode. So how much current it will be having a leakage? Let's say it is 1 milliampere or it is in microamperes. Okay, so if it is less, it is good. Okay, even same way quiescent current. So quiescent current will always come up, let's say it is coming up, let's say 10 milliampere or something like that when it is working, or when it is in shutdown, that time quiescent current may be almost negligible. Now coming to the fact that accuracy, so these days regulators are coming as good as 0.2% or 0.5% accuracies also. Earlier it was like 5% or 3% or 2% or 1.5% accuracies. So I mean, for your normal application, even 5% or 3% accuracies are good, but for very high end applications, generally people go ahead with 1.5% or 2% tolerance. What is the power supply rejection ratio? So it can vary from your, let's say 40 dB to around 80 dB or 90 dB also. These days are coming very good regulators. So I'll suggest you try to keep your PSRR range more than 50 dB. Okay, for your application. Now you must see what is the noise level that is available between 10 hertz to like 100 hertz or something like that. They have mentioned it. So that should be around 20 microvolt RMS or 40 microvolt RMS, or it is going to be, let's say 120 microvolt RMS. So the lesser the noise, the better the regulator. Okay. Next parameter for the regulator is like what are the different capabilities that the regulator is carrying out. So whether it is having over voltage protection, it means if my input increases more than the range, then whether it can protect itself, or it will shut down and protect itself. Similarly, over current protection. So let's say the output got short circuited, so a lot of inrush current will be drawn. So at that time it should be able to save it by itself. So these are the protection mechanism that should be available with the regulator if it is needed for your design. There are many regulators which do not come up with so many protection features, but these days the regulators which are going to be used, let's say in your RF applications or FPGA applications or your PLL or VCOs, or you need some ADC and DAC driver, I mean power supplies, So very high-end applications, you need these kind of like protections mechanism. So this is your thermal shutdown. If my temperature increases beyond the limit, the regulator should be able to save itself. Okay. Or short circuit protection, already I told you, like overcurrent protection, same way short circuit protection, over temperature, that's just like that. Thermal shutdown. So there are different terminologies for representing the same parameters. Okay. Even reverse protection, suppose your like the regulator is connected negative voltage and positive to ground, so it should be able to protect itself. So these are the different protection techniques that is available. Now, what is the operating temperature range? Let's say generally, like all the regulators are coming from like minus 40 degrees centigrade to let's say 125 degrees centigrade. So this is the temperature range that is, like available for the regulators working. It can go up to from like 0 degree to 70 degrees centigrade also, or 85 degrees centigrade also. Okay. Even very good regulators are going to come up with a temperature range of 155 degrees centigrade as well, but the general tendencies are minus 40 degree to 125 degree centigrade. Now the very like important thing that you require is your output current. So how do you decide what is the output current that I need for my regulator? So it can be like even 100 milliampere, 200 milliampere, 150 milliampere, or 500 milliamperes, or 1 ampere, or 2 ampere, 3 ampere, anything it is possible, right? So I'll give you an example. Let us say you are going to design, like microcontroller circuit, and you just need, let's say maybe a 25 milliampere current for this. Okay. So for this microcontroller, a 100 milliampere regulator will be enough, but I'll suggest you go ahead with around 300 milliampere regulators. Okay. For your normal application. For your very high end application, you can go ahead with 100 milliampere, because there will not be any room for extra consumption of the currents, right? But if you require a current, like supply of let's say 1 ampere, then I'll suggest you to go ahead with 2 ampere rating or 3 ampere rating for these particular regulators. If you need 2 ampere rating, then what will you do? Still you don't have to go ahead with 4 amperes or 5 ampere. You can still manage with your 3 ampere regulators, but here you are going to deal with more than 200 or 300%, but here 50% is more than enough. So for lower current application, you can go ahead with more rooms, like 100% more or 200% more. But for very high current applications, you may need like even 50% is enough. Okay. What is the mounting type of the regulator, like whether it is SMD regulator or through hole regulator, that you have to decide based on the heat dissipation that you want. Okay. So these days SMD regulators are also coming up with exposed pad. They help you to like spread the heat very easily, and that's how the temperature doesn't rise very high temperature. Okay. Through holes are basically like TO220 or that DD pack is there, through hole DD packs and all those things. Now ROHS you must consider, like the regulator which is like compliant with ROHS, like these days all these this is actually a requirement of IEC standards and all. Some more parameters like product status. What is the product status? Whether it is like active, or it is going to go in very soon. Let's say in one year, if it is going to go in, then you may not be like willing to take that particular uh, component for your design purpose. So you must like see the status of product, whether it is going to end in let's say maybe 5 years or 10 years or something like that. So that will be coming up under end of lifetime. So you can check this thing from the manufacturer website, or some of the third party website like Silicon Experts and all. And many data sheets are actually giving the applications as well, like what are the different applications that the particular regulator can be used for. So this will help you actually to choose for your uh, regulators, right? Generally, they mention whether it is going to be used in FPGA supply, or wearables, or smart applications, or something like that. Now, what we'll do is we'll take up some of the like part numbers for different operating currents or output currents. So this is just an example. Like there are many regulators that is available for 100 milliampere, but you can utilize TLV 760 for 1 milliampere, 150 milliampere ratings. You can go ahead with TLV 741P or TLV 717P. You can still go ahead TLV 709 or TLV 704 or TPS 709. This is actually new one. Okay. So 150 milliampere ratings. You can go ahead with these part numbers. For 200 milliampere applications, this is a very new IC that has been released by Analog Devices. Actually, it is a linear technology component, but linear technology was acquired by Analog Devices. ADP 151, LT 3042, MAX 8880, then ADP 7112, TPS 7820. So this is my preferred component. Okay, this is from Texas Instrument. TPS 720 because this is a new component and this is very low cost. Okay, so this can be utilized in your general applications for 200 milliampere or 300 milliampere rating. Actually, this is 300 milliampere rating linear regulator, so you don't consider it in 200 milliampere. Then TLV 709, so 300 milliampere as I as I mentioned you, TPS 7820 series. So if you want, you can have. Why I'm giving you this part number is this part number or any other part numbers are available in many output voltage range. Let's say you need 1 volt or 1.2 volt or 1.5 volt or 1.8 volt or 2.2 volt or 2.5 volt or 3.3 volt or 3.3 volt or even 5 volts. So all these voltages, these are very standard voltages that are generally used in your application circuits. Okay, for any high end or low end applications or smart applications or industrial applications, commercial applications. So these are the general voltages that are generally used. So this particular IC or this particular linear regulator is available in all the voltage range. Okay, with different packages also, like it is having SOT package as well as WSON package and X2 SON package. So X2 SON is still smaller. These are even less than 1 millimeter cross 1 millimeter. Okay, even BGA package is also available with this particular linear regulator DSBGA. Okay, so some more are like, let's say 1 ampere rating. So 1 ampere rating, you can go ahead with TLV 1117 LV or LM 1117. More parts are there. I'm just giving you some examples. For 1.5 ampere ratings, if you need, you can go ahead with TPS 7A47 or LT1963A. So LT1963A will be my preferred choice because this I have used in many applications. 2 ampere rating, you can go ahead with ADP 1740. Even TPS 7A96 is available. For 3 ampere ratings, generally you may need 3 ampere linear regulators for your FPGA applications and high current applications. So for that, you can go ahead with ADP 1763 or LT 1764A or MAX 17510. So these are the regulators that you can utilize. Anyway, I have tried making a sheet of different regulators that is available from different manufacturers, like Texas Instruments, Analog Devices. At the same time, Linear Technology and Maxim Integrated is under Analog Devices. Okay, Microchip Technology is one of the best company for your power management regulators. ST Microelectronics is there, Diode Incorporated is there, Infineon is there, Monolithic Power System is also one of the good company. Rome Semiconductor is also having lot of linear regulators portfolio. Renesas is there, which is one of the best company for linear regulators. So some of the part numbers that I have listed here, so you can make a note of these things, or if you need, you can put down your comments in the comment box, and I shall be able to give you a part number for your application. So these are the the part number must be selected based on the application specific. Like what is the application that you need for, so based on that I should be able to decide whether you need a little bit bigger package or a smaller package, or it may be a BGA package. So what are the criteria that you require that I have explained you? Still, if you do have any questions or any like queries regarding your particular projects or anything that you are looking for, please put down your comments in the comment box and I shall come up with the answers. Thank you so much.